For this problem, to solve for x and y, I'm going to use elimination. So I'm going to subtract the second equation from the first, put parentheses around the whole equation so that I remember to distribute the negative sign. 5x minus 5x is 0x, so that goes away. I get negative 5y equals 20. Now I divide each side by negative 5. Y equals negative 4. Halfway done. I need to find x. I'm going to plug negative 4 in for y into either equation. So 5x minus 2 times negative 4 equals 25. 5x plus 8 equals 25. Take away 8 from both sides. I get 5x equals 17. And I divide by 5. That cancels out. And my final answer is 17/5 for x, negative 4 for y. For this example, I'm going to use elimination again, but I'm going to multiply the second equation by 3 so that I have this 15y will cancel out. Okay, now I'm going to add the two equations. I get 18x equals 90, and I divide by 18, and I get x equals 5. So we have x equals 5. We plug 5 back into one of the other equations. You see the work done there on the left, and we divide each side by negative 5, and we find that y equals negative 1, and there's our intersection point. In C, I see I have a negative 4y in both equations, so I'm going to subtract the second equation from the first equation. And when I do that, x minus 3x is minus 4x. The y goes away. 24 minus 16 equals 8. Divide each side by negative 4, and x equals negative 2. I then substitute negative 2 back into one of the two equations. Minus 2 minus 4y equals 24, and I will solve for y. And I get y equals negative 6, so my final answer is negative 2, comma, negative 6 is where they intersect. D. For D, none of the x's or y's match up, so I'm going to multiply the first equation by 2 and the second equation by 3, and then subtract the second equation from the first, and you'll see that x will go away. So I've made sure to multiply every term in the first equation by 2 and every term in the second equation by 3. I now subtract the second equation from the first, and I get x's go away, plus 15y, so I get 19y minus 9 equals minus 29. Divide each side by 19. Y equals negative 29 divided by 19, or negative 1.53. I then plug that y value into one of the equations, so 3x plus 2 times negative 1.53 equals negative 10, and I do the math. And I find x is negative 2.31, and my y was negative 1.53. This equation I must solve by graphing. Remember, what we do first is we get rid of the inequality, and we say y equals 4x minus 1. So in that case, I'm going to do that one in red. So negative 1 is the y-intercept, and then I go up 1, 2, 3, 4 over 1. There's my second point. It's just greater than, so this is going to be a dotted line. I then must pick a point and test it. Now 0, 0 is pretty close. The way I've drawn it, it could be on either side of the line. So I'm going to check the point 2, 0. So right there on the x-axis, I'm going to check that, see if it's true. So y is 0. 4 times 2 minus 1 is 8. 8 minus 1 less than 0. It is not, which means I'm going to shade above. So I'm going to shade on this side of that line. Then I do the same thing for the second line. And I'm going to do this one in blue. Y equals negative x plus 4. The y-intercept is going to be 1, 2, 3, 4. My slope is negative 1, so down 1 over 1. And I go ahead and I draw that line like so. 0, 0 is obviously below it. So is 0 less than or equal to 0 plus 4? That is true, so it's below the blue line. And so my intersection is going to be this area in here. For B, I'm going to do the same thing. First one I'll do in blue. So I'll say x equals negative 3. So I find negative 3 on my x-axis, and it is right there. Well, pretend I went through that point. So that's x is greater than negative 3. So I need a shade on the right side of that. Next one I'll do in red. I have negative 3x plus y equals 6. If I wanted to solve that for y, I could get this equation. So my y-intercept is going to be 6. So 1, 2, 3, 4, 5, 6. The slope is 3. I could either go up 3 and over 1 or down 3 and to the left 1. Since that's kind of on the graph, I'll do that one. And that is going to be that line. 0, 0 is clearly below it. So I plug 0 into the original equation. Oops. Greater than or equal to 6. And 0 is not greater than or equal to 6. So it's going to be the other side. So we're going to end up with this sliver in here. For number 3, it's a word problem. You can read the word problem. The items cost $1 or $5. Let X stand for the number of $1 items, Y stand for the number of $5 items. And I spend less than $45. So I'm going to let X stand for the number of $1 items. So X times 1 would be how much I spent on $1 items, plus Y times 5. This must be less than 45. The only other equations you'd want to think about would be X is greater than or equal to 0, and Y is also greater than or equal to 0 because they stand for the number of items. To graph this equation, X plus 5Y equals 45, I'm going to find the X and Y intercepts. If I plug in 0 for Y, I get X equals 45. Come out here, I'm going to mark that 45. If I plug in 0 for X, I get 5Y equals 45, or the Y-intercept will be Y equals 9. So I'll call that 9. I then graph it. I'll graph it in red, and it's going to be a dotted line between those 2 points. Because X is greater than 0 and Y is greater than 0, both put me in the first quadrant, this quadrant here. So I shade, and the area that I can pick a point and have it be true would be this triangle right there. In this equation, we're going to create a garden, and we have a rectangular garden. It tells me that the garden can be no more than 30 feet wide, so which tells me then that width must be less than or equal to 30. The other thing it restricts is the amount of chicken wire I have, and I have 180 feet of it, so the total that goes around the edge must be less than 180. So that would be 2W plus 2L because I have 2 widths and 2 lengths. And the other 2 things to think about are that W and L both will have to be greater than or equal to 0. So I made my graph for the first quadrant. So W, I'll make this axis W, I'll make this axis the length. W is less than or equal to 30. So I'm just going to put 30 here. Don't make 30 little tick marks. And then that's going to be a vertical line. And it must be less than that, so it's going to be in this area here. The other one, 180 equals 2W plus 2L. The two intercepts are going to be 90 for W. If I plugged in 0 for L, I'd have 90 for W. And the same thing, if I plugged in 0 for W, I would get 90 for L. So that is going to look like that. 0, 0, if I plug into this equation here, it is true. So I'm going to shade below. So my final answer is this shape right there. For number 5, we're mixing two ingredients to get a third. So we're going to let X stand for the amount of 30% solution. Y stand for the amount of the 50% solution. So it tells me that we're going to have 200 liters at the end. So one equation, X plus Y equals 200. The other equation talks about the insecticide. The final answer is going to be 42% insecticide. So how much insecticide is in that final thing? 0.42 times 200. The X is going to contribute, that's 30%. The Y is a 50% solution. So that's my two equations. And it asked how much of each solution should I use. So what I'm going to need to do is use substitution. I'm going to take the first equation, I'm going to solve it for Y. Y equals 200 minus X. Then I'm going to substitute that in for that Y there. And I get 0.3X plus Y, which is now 200 minus X, times 0.5 equals, and when you multiply 0.42 times 200, you get 84. Now I just distribute and solve it. Here I just distributed the 0.5 and the 3. Now I combine like terms, get X on one side, and move the 100 to the other. You see we get 80 liters of the X solution. The Y solution then will be 120 because together they must get to be 200. All right, that's it for Chapter 6. New video for Chapter 7.